Okay, everybody, wake up. We're going to get ready for the next session, the industrial session, and I want people to recognize that we had a very busy committee that worked very hard to put together these industrial panel sessions. And I think, in addition to the keynotes, you'll find this to be a major highlight of our conference here. Uh, these industrial panel sessions, the reason why I'm saying there was a lot of work associated with it, these are all invited sessions. The members of the panel had to come up, the members of the committee for the industrial panel sessions had to come up with the titles and then go out and actually recruit people to bring them in. And we've ended up with what I think are really important a group of people who have something very important to be able to say to you. So I think you'll find these industrial sessions, which happen at 10:45 each day, each morning, we have a different panel that you'll see. The first one that we're going to hear now is titled Leveraging Consumer Technology and Applications for Public Safety. And it's organized by the Senior Director for IEEE Future Directions, Kathy Grease. Cassie Grease is here, there, and everywhere. She's involved in just so many things within the IEEE and so many of the next generation and future technologies and emerging technologies. And makes a really important contribution to IEEE in general and certainly CTSOC. So Kathy is the Senior Program Director for IEEE Future Directions. She supports new and emerging initiatives, including cloud computing, big data, digital reality, AI, machine learning, digital twins, digital transformation, public safety, and supports IEEE Future Directions. She manages the digital presence team for Future Directions. She serves as the technical program chair of IEEE ComSAC 2025 Symposium on Data Sciences, Analytics, and Technology. She's a 2024 recipient of the IEEE Eric Hertz Outstanding Staff Award, and prior to joining the IEEE staff, Ms. Grease had numerous positions at IBM, and most recently was a senior engineering manager for process design kit enablement in the IBM Semiconductor Research and Development Center. She led the overall IT infrastructure implementation and software development in support of semiconductor device modeling, verification, packaging and delivery, device measurement and characterization of data collection and management, and automation for device modeling engineers. She's a graduate of Washington and Jefferson College and an IEEE senior member. And if I kept reading, there wouldn't be any more time for the panel. So thank you so much and welcome, Kathy.
Stu, that you didn't need to keep reading all that. That was wonderful. Thank you very much. Good morning, everybody. I'm delighted to see all of you, and I do want to thank the organizers for inviting us to be here today. And all of you, I can say, are affected, and hopefully you will find our discussion today very interesting because it does affect each and every one of you in this room. And hopefully through today, you'll see how it might touch you and encourage discussion too. So think about your questions, your comments that you'd like to ask. But first, before I go into the topic at hand, I wanted to talk a little bit about future directions. I know a lot of people are not familiar with what is future directions. Think of us, we're a small committee, but we are the sort of informal research and development center for IEEE. We look at new and emerging technologies where IEEE should become hopefully a thought leader in that area. For this year, we're looking at a whole bunch of areas. One example on the upper left is a 5G, 6G innovation testbed. You're thinking, what is that? Okay. It's an application-based, web-based tool where it allows a third-party supplier that is creating 5G or 6G applications, they can go out to our server and test their applications, and it's using the various standard protocols and everything. We also have a range of like the metaverse, smart lighting, telepresence. Telepresence is fascinating because we had a competition, if you can believe it, in the Southern California desert a couple months ago, where we set up a robotics competition. And what you do is telepresence is like, think of teleporting a physical being with a virtual connection. So we had quite a few student teams competing, and it was a lot of fun, and we're hoping to repeat that again. Also, we have wireless power technologies. Think of that as like the mag chargers, but on a much bigger footprint. And then we also have low Earth orbit satellites and systems. And as you can imagine, that is such a critical aspect in terms of communications, especially on a consumer-based. The other aspects of what we do are, it's not just like any single technology, but all technologies in today's environment, the 21st century, are interconnected. And there we're looking at more the softer aspects of the technology and how it impacts humanity. We're looking at things like digital privacy. What are all the different technologies that are related to the privacy of the user? Public safety is the other one, and we'll talk more about that in a moment. There's another one too that's called SUSTech, and that's looking at all things that improve the sustainability of our planet. We're looking at technology roadmaps, very relevant to industry. We also, and I saw Kathy Hayashi in the room here, she's the chair of our Global Semiconductors Ad Hoc Committee. And that's addressing not just the United States Congress where they passed the US CHIPS Act, but also there are CHIPS Acts that have been passed like in Singapore, across Asia, Europe. And this is looking at addressing from a semiconductor perspective, workforce skill development, because that is such a key thing. Also supply chain issues. So that's all part of Global Semiconductors. AI Coalition is another one. We didn't start a new initiative on it, and I know Stefan Moser is here. It's really to identify all the areas across IEEE that are working on AI, because AI is ubiquitous and there's not any one group that's working on AI. So we did an inventory last year to identify the gaps, and from those gaps become our opportunities to put projects together. We also have an industry advisory board. It's chaired by an HPE fellow and Vice President Dejan Milosic. And if you have interest and you want to contribute, come and see me, because we form a board and we look at putting together what you think are the new things in terms of tech predictions. And we put together a report, it's written, and we publish it. And I know a lot of you are experts in the field. Please contribute, join. There's two areas that we're thinking that we might start this year. Smart agri-food. You know, think about all that. And I don't know if some of you went to CES this year. A lot of keywords in terms of smart this, smart that. So IEEE is right in there. And then the other one is looking at new alternative energy generation storage. I know Tom is working on data storage, but this is energy storage. Spotlight on public safety technologies. Just a short primer. You're thinking, what is really the definition of public safety? It's simply protecting the public and keeping them safe, preserving life, properties, and the environment. The technologies we use are cross-cutting. They may range from AI, machine learning, to Internet of Things, 5G, sensors, you name it. And you'll hear more about that in a moment. Public safety industry is divided into several segments. Think of it at a public government level, commercial. It's big business, if you can imagine. suppliers and service providers, all the different cell carriers, communications carriers, associations. They range quite across the board. Think about Red Cross, right? That really is an enabler of public safety. And also, Standards Association for IEEE is involved. Public safety areas, it's everywhere. Prevention, protection, mitigation, response, and recovery. Here are the various emerging technology areas to think about that affect public safety. Data, it's everywhere, and it's continually amassing huge, and I'm gonna like zotabytes, and then they address AI, machine learning, emergency response. Software is key, all the different applications behind that. Also, think about from a biotechnology, all the informatics behind that. Blockchain, you're thinking, well, is blockchain really real? Or is it all hype? It is really being used in disaster record management and protection of it. Mixed reality, all the different AR, VR, extended realities, and communications and networking, all of them come together to support and advance public safety. Public Safety Technology Initiative for IEEE. There's our website. You're welcome to go out there and check it out. We have our flagship conference. This will be our second year that we're holding it. It'll be in Orlando, Florida. For those of you that are looking at becoming authors, submitting papers, if you have an idea, a concept that involves any type of technology and talks about public safety, consider submitting a paper. This is where we've also had last year, the Move Truck came, and we talked a lot about the program behind that. We've got some special issues. And we also, I already talked about test bed for 5G, 6G, but we're also looking at a digital twins type of test bed. So that is good for industry, standards and roadmaps, collaborations. I don't know if you're aware, I wasn't, I learned this one last year. Singapore, their country, they actually have an agency on public safety. And we're collaborating with them and along with the Move Truck program. And then we contribute to conferences like the one that we're at here today to get the word out. Now we'll switch to the panel. I'd like to invite Nick Knapp to come up and talk about his perspectives. Nick has a long history in terms of just looking over and leveraging technology, and a long history in industry.
Thank you, Kathy. Good morning, everyone. Thanks to ComSoc for inviting us to talk, and to Future Directions for putting this together. So the topic of our panel is leveraging consumer technology and applications for public safety. And I have a vested interest in this because my company has been working on a device that plays directly into this, which we're going to talk about a little bit. But what I really wanted to talk to you about today is the use of consumer technology as an approach towards digital twins to make them practical for a broader audience. So just a very quick show of hands. Has anybody in the room not heard the phrase digital twin before? Okay, so it's been something that has been discussed at some length for the last 10, 15 years. And the examples that are usually given are things like companies like Boeing and Ford, right? We have an entire aircraft that we are monitoring in real time. We have a virtual version of that, hence the digital twin, that is receiving real-time data from a physical device somewhere. And so, a lot of the time we're talking about, as I say, airplanes or automotive designs. There are entire cities and countries like Singapore where an entire digital twin has been created to reflect all of their infrastructure, so they can see real-time patterns of traffic and weather. They can do urban planning and run different scenarios, all using a virtual representation of the city, but using real data. Companies like Unilever have documented savings in the tens and hundreds of millions of dollars by taking their incredibly complex supply chains and modeling them with digital twins so that they can make them more efficient and spot issues and challenges in their supply chains quicker. But the thing that all three of these examples have in common is that these are multi-million-dollar investments by billion-dollar organizations. These are not small undertakings. And so that really begs the question, are digital twins really only for these big corporations, these big organizations, and fundamentally for the wealthy, which is not most consumers? And I would argue no. And the reason that I would do that is because fundamentally digital twins help anyone understand complex data. And as I think probably everybody in this room has seen, the amount of data that we all deal with in our day-to-day lives has grown exponentially. And that's a very overused term, but it truly is beyond exponential when it comes to volumes of data. And I would also argue that digital twins do not have to be these incredibly expensive multi-million-dollar investments if you just modify your expectations a little bit. And that's where it kind of dovetails for me rather interestingly with public safety, which is really the focus of this talk. And of course, you're here to look at and talk about consumer technologies. So we have to answer the question, what role can consumer technologies play within this idea of digital twins in public safety? So another question for you all. What are you all exposed to every single day of your life? Give you some clues. It's invisible. It is quite literally everywhere. And it is largely unmeasured. The answer is indoor air quality. We all spend a great deal of time indoors. By and large, in buildings where there is no measurement happening whatsoever. Unless you are in a laboratory environment, there is probably no real-time measurement happening of any of the spaces that you spend most of your life in. And what are the key components of indoor air quality? Well, typically we're talking about temperature, relative humidity, carbon dioxide levels, volatile organic chemicals, VOCs, and particulates. Those are the main things that we care about. And the vast majority of buildings, again, that we all spend every day of our lives in, collect zero data on these things. And to understand why that is potentially a huge problem, we have to take a little side journey and look at a brief history of buildings. So back in the 1970s, which for some of you will seem like a very long time ago, and for others of us doesn't seem quite so far ago, but there was a very significant worldwide energy crisis. And as a result of that, it became much more common to really start to seal buildings more effectively in order to save energy. And, this was great. Buildings became a lot more efficient comparatively. But of course, it was terrible for indoor air quality because now the air is not being changed within your buildings. And an enormous number of commonly used building materials off-gas volatile organic chemicals. So for example, in this room, the ceiling tiles, the paint on the walls, the carpet, probably the formica in the tables, these chairs, all of those things are going to be off-gassing VOCs. And if your building is sealed, there is nowhere for those to go. So they just accumulate over time. So how bad can it be? You probably don't want to know the answer to that in some ways. Let's focus on temperature, right? If the temperature is very uneven in your building, that's going to lead to discomfort and stress, which is unpleasant, but is manageable. However, once your carbon dioxide levels get too high, you're looking at poor concentration. If your VOCs are high also, you very quickly get into dehydration, nausea, cognitive impairment. These are very real things that have been documented very clearly. And of course, with humidity, which is something we tend to not think about so much, except when we spend a week in Vegas, when your humidity is below 20% or above 80% relative humidity, any kind of airborne disease is going to last for significantly longer. So your transmissivity of anything airborne goes through the roof. There have been a couple of papers published that indicated this is why during COVID, senior living facilities were so heavily impacted, because a lot of senior living facilities are obviously very sealed environments, and they use predominantly electric heat, and so they tend to be very, very dry, and that led to COVID basically lasting for much longer than expected. Another term you may have heard is sick building syndrome, which is basically when there are buildings that people just don't like to be in, and the illness rates are higher and so forth. That is basically a result of a combination of these factors: VOCs, carbon dioxide levels, and so forth. And of course, all of this impacts your operating costs for your building. It drives up maintenance. If your humidity is too high, your paint's going to peel. If your temperatures are uneven, you're going to have other issues. And of course, all of that impacts your energy usage and your carbon emissions, and potentially also liability issues. And of course, remember, we've been sealing buildings up without measuring them since the 1970s. So, this is a pretty problematic area. So the way I got into this was working with a company that tests fume hoods in laboratories and fixes ventilation in labs. And in discussions with them, it turns out that most building sensor technology today is hardwired. Much of what you buy on the market is hardwired and really designed just for those laboratory environments. So it's incredibly expensive. It's expensive to install. It's very disruptive. You have to have contractors drilling holes in your walls, running cables, and so forth. And so the device that we've been working on for the last couple of years is an all-in-one device called Nosy, it's called Nosy because it's nosy about your building, and it is designed from the ground up for affordable retrofits. So what we did from day one is embrace a lot of consumer technology. We have a number of sensors in the device that come straight from the mobile phone industry. The device itself uses Bluetooth mesh, so it's very low power, and we've taken a very consumer approach to the ease of use in terms of installation and usage of the devices. And we've been able to pack quite a bit in there. It measures temperature, relative humidity, atmospheric pressure, VOCs, carbon dioxide levels, light levels, and it also tracks occupancy. Because one of the things that you can do to really improve your energy efficiency in a building is just set your heating and cooling to work when people are actually active in the building. And while we may all have programmable thermostats in our homes, an enormous number of commercial buildings simply don't have that. So each one of these sensors takes over 2,500 readings per day, and all of that data is aggregated by our platform, and then we analyze it to tell you things about your building so that you can actually improve it. And we were recently awarded a Phase 2 SBIR grant, Small Business Innovation Research grant, by the National Institute of Standards and Technology. And part of what that's funding is developing ways that we can take our data and automatically change the settings in your HVAC system to make it more efficient and better operating. So let me walk you through a little bit of what this looks like and then tie it back to the subject of digital twins. So this is a floor plan of a high school. It's the upper floor, and in the middle, you've got a relatively recently renovated STEM area. So that's all very new with new HVAC controls. Most of the rooms around the perimeter are on the old system, which is a steam boiler system. The building itself was built in the late 1800s. And the blue X's that you can see represent the sensor locations. Now, the typical way that most sensor systems report data is with charts like this. So each one of these lines that you can see represents an individual sensor location. The orange line that you can see that's a bit lower down is the outside weather that we pull in doing an API lookup. And you can see that some of the peaks on the lower orange line match peaks for temperature from the sensors. And that's because there are rooms that have really terrible insulation. So, just from this, as somebody who's spent a lot of time looking at these kind of charts, there's a bunch of things that I can see here that are concerning. And here's another example where, again, we can see that as the temperature has risen outside, there are a number of sensors where the temperature has risen in the building. But I can make sense of that because I have spent way too much of my last couple of years staring at charts like this. For a typical layperson, a facility manager, somebody responsible for a building, those charts are not very helpful. So what we did was we created a very simplistic 2D digital twin. So we have a map view because everybody's familiar with maps. We understand how those work. This is a layout of the building, and each of the black dots represents a sensor location, and we use simple color coding to tell you what's going on. And then in the top left corner, you can see a thermometer that's showing you the outside temperature. And so since everything more or less is green, we can see one bit of blue in the middle, which implies that that room's a little cold. But we can see at a glance where the problems are. And so what we do is we give you snapshots over time. And we can see we're now at 11 o'clock in the morning, and some of the rooms are starting to show as being a little warmer. By 3 o'clock in the afternoon, you've got pronounced heating all down the left side of the building. And the smaller box towards the top is a stairwell. And that stairwell typically reaches 92 Fahrenheit. So that's 26, 27, 28 Celsius, somewhere in there. And what we're able to see from this data is that there is one side of the building that is very aggressively being heated by sunlight in the afternoon. The north side of the building is shaded by another building, and the other sides have trees. And so in this case, once we could show them the actual data, and you can see that this heat, we're now at 7 o'clock in the evening, you can see that the heat is lasting because that, the room has absorbed it. But we were able to see exactly where the problems lay with temperature. And that allows us to start to look at root causes. And the thing that is important here is that when you have this level of data, the issues can be solved often at very low cost. And in this case, all we did was they're putting solar window film on the windows on that side of the building, which cost a few $100s and will make all of those classrooms far more pleasant to be in. And we can take exactly the same approach with the data for humidity, volatile organic chemicals, and carbon dioxide. So I'm actually going to show you some live data that I recorded. And what you're going to see here, this is relatively recent. You can see the date range. It's basically from November the 12th, so quite recent. The red dot indicates the room that we are particularly concerned about. And when I click play, what you're going to see is starting from midnight and going through until midnight at the end of the day, you're going to see playback of the VOC levels for the building. So whilst, we're at 2, 3 o'clock in the morning, right? So nobody's in the building yet. As soon as we get past 6, you start to see purple is bad. That is very bad from a VOC point of view. So you can see once the students are there, generally the indoor air quality goes down pretty badly. Now we're heading into the afternoon, 3 o'clock, the students have left, and so naturally the VOCs dissipate. But using that data, we can very easily, again, we've developed another consumer level device that effectively is a door chime that will go in the classrooms, and it just chimes when the air quality has gone below a certain threshold so that the teacher can know to either switch on a fan or open a window, which again is a very low cost remediation, but it solves a very real problem. And this can be applied to any kind of commercial building, and very quickly using the data, not only can you improve your energy efficiency, but you can improve the health and well-being of the building occupants. Where, in fact, we just started a study. The school building tends to get very, very dry in the winter when the heating is on and the windows are closed. It's located on the east coast of the U.S., just south of Boston. And so we're currently doing a correlation test to see if student absenteeism increases when the humidity is dropped, because the school has repeated issues at certain seasons, certain times of the year, when more of the student population gets sick more often. And it certainly looks like humidity is a big culprit there. So I would hope that all of you, in looking at that video, fairly quickly became pseudo-experts on which rooms had bad levels of volatile organic chemicals. It makes it very, very easy to see exactly what's going on. And that fundamentally is the point of a digital twin. It's to make complex data far more understandable and actionable. And as I hope we've demonstrated here, a simplistic twin, digital twin, really can be both functional and very affordable. This approach that we're taking is typically about 20% of the cost of a traditional building retrofit. And even this simple example can deliver some pretty useful insights and real value for users. You know, for the school, they're looking, they've already made changes. We've been able to identify faulty thermostats in the building, so students are already reporting much better thermal comfort. Next up is to address the indoor air quality and the humidity, which will happen over the course of this year. Well, and I'll stop there, and thank you for your time.
Thank you very much. Hello? Okay. All right. Thank you very much, Nick. That was very informative, and I hope all of you got a sense that there was a lot of different technologies that weighed in, a lot of generation of data, sensors, IoT, and just old-fashioned circuit design too, in this case, with your device there. One of the things is to think about, you're thinking, well, you know, in the building, how's that involves public safety? Well, Nick talked a lot about like the health and well-being of our students as well as the teachers and staff, right? And I have to say it kind of correlates with us being in this room, because in Las Vegas, boy, it's dry, isn't it? And nothing against the smokers, but I really can smell that smoke too. And so you can imagine, right? Nick really, really highlighted air quality, and I think that really does affect our safety and well-being. So I'd like to then welcome Tom Coughlin. And I have to say, a dear friend of mine, you know, for Tom here, and he really helped me out here, because I want to highlight too and recognize two people who could not come today, and I didn't say that in the very beginning. I had invited Ann Cohen. She's an ocean scientist to come and speak, and she traveled to South Africa over the holidays and to visit family. But then she fell ill, and so it was just 2 weeks ago she reached out to me. She's like, I really was planning on coming here. She wanted to attend CBS that she's never been. And then she's like, nope, I'm going to make it. Then just 1 week ago, she's like, I'm still in South Africa. So, and then she managed to get a colleague of her, another principal investigator, and on ocean science and everything. And so, and that person is Nathan Malik. Nathan and I talked just a week ago Friday, and he said, oh yeah, I can do this. And he made his flights and booked his hotel. 2 days ago, he texted me, I came down with COVID. So I just wanted to let you know, and I will share some of their slides that they shared with me too, just so you get a taste from a topic area of you know, what's mean with ocean science. So, but with that said, I really want to truly thank Tom Tom Coughlin is our 2024 IEEE President and CEO. And Tom is an amazing entrepreneur, particularly in the data storage area. One of the things I asked Tom to think about from a public safety perspective is, what's the impact of data, as well as potential storage requirements. But also, Tom's going to share a little bit about some fun notes too.
Thank you very much. Is that can across? Yeah. Okay. And Nick, that was pretty cool. How you can make a low-cost digital twin of, like, for instance, a school. Yeah. Just to address some of the things that Kathy brought up here. Thank you very much, Kathy. And I do not have a presentation, so I didn't know I was on this panel yesterday. But if you notice, Nick was talking about all of these sensor data. So the total amount of information that's being created because of all the sensors, cameras, everything else is just incredible. And all that stuff has to be stored somewhere, if nothing else, at least temporarily, so it can be processed, for instance, for training models, things of that sort. Digital twins is part of that, but the other part of that may be, could I use this to create some artificial intelligence model that might be able to help me in terms of automatically control that environment, for example. So there's been a lot of and AI and applications, of course, and I know that's a big topic at this conference as it was at the CES show, can require a fair amount of processing and also a lot of memory and storage. So I just want to put that out there that a key part of doing this is where you keep the data and what you do with it. And there's, having been at the CES show, I saw an awful lot of edge and endpoint devices, especially embedded devices that were implementing various types of artificial intelligence training. So this stuff is going to play a big role in our consumer devices. But likewise, when you run into, it can be used for general public safety. But the other thing is, what if you have an emergency? What are some of the things that are happening on that? And with that, there's, I'd like, for instance, right now there was fires going on in Southern California. In fact, my wife, family, one of her relatives had a house that was burned down. And for a while there, because the fires are so fierce, a lot of the cell towers weren't working, a lot of the regular communication wasn't working. And so they're using satellite communication to be able to, for the first responders, try to coordinate their activities. But another resource, which is kind of sometimes an unseen consumer resource, is amateur radio operators and the role that they often play in emergency situations. So I'm sure that that's been true in the fires in Southern California, but also Kathy was reminding me, saying during the 9/11 in New York City back in 2001. Also, apparently the fire and the police did not have a common radio system, so they couldn't communicate back and forth. So apparently ham operators came in and were helping in that situation. And also IEEE, the organization to which we belong to, whose mission is advancing technology for humanity, has an activity that's meant to aid for disaster recovery called MOVE. That started in the U.S. They basically operate on trucks that work with the Red Cross in emergency situations, but they also are expanding that out into other countries and areas as well. So, emergency response using all manner of consumer type devices, whatever way you can communicate would be good. In fact, that's a place where, being able to move from one sort of communication or channel to another as they're open and available could be a very good resource for emergency situations. So again, I don't really have a presentation per se, but there's some things I can talk about. I just wanted to point that out that, public safety, of course, is an ongoing effort, but also when there are emergencies, it plays, resources that we have, including all of our consumer technologies, can play an important role in helping people to deal with those.
Thank you very much, Tom.
Oops, I should have advanced that. Okay.
Oh, there I am.
All right. This is in the event that if Anne first was able to come, or then Nathan. But I thought it was important to share a different perspective Nick talked about digital twins technology and the use and application at a consumer level, but more for like buildings. This takes you down into the ocean from a water perspective. This team, particularly the Woods Hole Oceanographic Institution and Eddy Analytics with funding from NSF and the TNC, they put together digital twins technology to address and how to improve the overall coral reef. And again, this is really affecting the public and the safety. What is a digital twin? Here's a different viewpoint. It's founded in real data. Again, we're talking about data. And it uses data to force models that enable scenario testing. So you can think about it's also connected to the real system, and it provides real-time, intuitive, actionable information. So if you think about it, in this case, from an ocean perspective, it's measuring like, again, ocean still generates air, but it's also like the water temperature, the salinity, the overall quality of that. And it helps then to mimic and allow you to improve the coral reef. So there are several baseline components of living digital twins for the coastal systems. There's a lot of different levels down to sublevels here, different like habitats and sediments. So you can think about all the different layers. Here's an example of Hawaii, and you're thinking, okay, where is this taking me? I don't know if you remember, a couple of years ago now, back in 2023, the fires in Lahaina. And I'm just thinking when Tom talked about the fires in Los Angeles, my goodness, we are constantly having fires. And so this is demonstrating a digital twin tour of Hawaii. We're using satellites. Tom talked about that too. And then think of it as a large-scale model. And it gives you different resolutions down to the 4 kilometers. And you can see the different colorations here in terms of validating and visualizing how Hawaii looks. So again, it's going down deeper levels, even further. And at this point now, it's showing you the simulation of the digital twin down to the coral reef, down to 30 meters. And so this is now providing that data visualization of the digital twin. So it represents then the line of the reef, but down to also below the water and the corals. It's continually running, and so you're getting real-time data and all the different elevations beneath the surface of the water. And I'm highlighting this area. You can see that it's a little shallower, but also there's some impact here in a moment. This is where the digital twin, and it's at the time we weren't quite sure about it, but how could we have predicted where the pollution might affect from the fires? Because that pollution, there's runoff that goes down into the ocean, and that affects all of our potential water and the overall environment. So here's the runoff. There's the first flush and the 4-day forecast. You can see now slight area in the city and that runoff. And you can see how that relates back to the previous slide that I'd showed you, that little blue area. And you can see how the runoff has affected the water quality, thus impacting the wildlife and the coral reefs. And it helps identify the areas that public safety, like first responders, could address, environmentalists, scientists. Again, another visualization. It helps to zero in on all the different hotspots. And then here's another example. This is outside of Pearl Harbor. Because one of the things that is real is coral reefs are sort of an indicator of humans, because the coral reefs are dying worldwide. And so if we can use technology to help improve and regenerate the coral reefs, it helps us overall. Here's the present day coral cover outside of Pearl Harbor. And then looking at the wave energy on that. And then how it degraded and now rebuilding, regenerating the artificial reef that helps to improve the overall environment and regrows the coral reef. So here are some of the examples. And this was all built upon the research and development of their first twin. And that's how I came across it, because I ran across the study and the actual examples that came to play. This is the Palmyra Atoll out in the Pacific Ocean. Back in World War II, the Allies bombed the heck out of the islands around there and the reefs, and they literally almost destroyed the coral reef. So if you looked at the pictures back then that were taken, it was dead. And so what they did was they created a digital twin of this atoll, and again, identifying like the salinity, the temperatures, the current flows and everything, and identified the spots that were opportunity areas to regrow, and thus working with the various governments and scientists, they were able to regenerate the coral reef to its condition today. It used a network of the digital twins to help generate that. And so luckily they've been able to replicate that. So I just want to attribute Anne and Nathan and just improving the overall environment of the ocean there. One of the things I want to point out as an anecdote too, for those of you that remember the cargo freight container, shipping container that ran into the bridge in Baltimore Harbor, okay, that clearly impacts our public safety. And so Anne had called me up and she's like, boy, we could have used our digital twin technology to help manage the impacts. Because if you imagine that ship container, oil releasing into the water, and just the impact over that. And so, again, that could help improve our public safety. So thank you with that.
So want to see if anybody has some questions while we're doing that. I'd like to kind of pose some questions here. We've talked a lot about like impacts to public safety, but we talked a lot about digital twins, but I'm just wondering in terms of like the AI and everything, what are your thoughts in terms of how we can use AI for better good of public safety? Tom, you want to take it?
Let me see if it's on.
Well, so I went to Jensen Wang's talk at the very beginning of the Consumer Electronics Show. He was showing all manner of different GPU-based
Nick.
AI models and that sort of thing. And there were digital twins. Actually, it's one of the big topics that they addressed. Of course, it's driving a lot of activities where we think about how we can model actual things that go on. I think what Nick brought up is a good example of doing that, but it's possible to create, I think, even more capabilities of, we have so many sensors, cameras, things that are out there to use AI to be able to train models to be able to identify problem situations, or congestion, all manner of different things. We already have that to some extent, with the GPS mapping function we have, which in a sense are kind of a big network of, if you get the information back from the drivers, for example, or from which there are things that do that, or from the cars themselves, there'd be even more opportunities for dealing with the potential situation as they arrive. Looking for emergency situations or developing activities that could be a problem, or things of that sort too. So I think there's a lot of opportunities for using not just the big GPUs, but using the consumer devices that exist all around us, whether it be systems in cars, systems that are built into our watches or phones and things of that sort, in order to be able to create new opportunities for training and be able to look for deal with public safety issues, whether it be emergency or other types of or more effective use of facilities and things of that sort.
You were talking about emergency personnel too. Any thoughts, just kind of follow on to your response here? What can emergency personnel do with AI?
So one of the things I think of automatically is there are oftentimes, especially like in this fire situation in San Francisco, where you couldn't get enough people on the ground to deal with the issues, just overwhelming. Fire with winds like they have there can spread so fast. So are there things we could do with autonomous vehicles running on artificial intelligence to help the responders to deal more with it? Drones certainly were being used, but are there other types of devices too? And I know that's a little bit of a challenge because, in many cases they're dealing with fires in remote areas and things of that sort. But it seems to me that there are definitely opportunities for using artificial intelligence built into vehicles, things of that sort, that might be able to help in some of these situations. Maybe water was a real problem, having enough water, right? It's a fairly dry area to begin with. But are there things you could do that, besides water, like even just having somebody go in and pour sand on an area, might help it. It's a little bit difficult, the situation, of course, because there was so much wind, it was blowing everywhere, like miles, like a mile away from where the fire was and starting new fires. So, but maybe there's ways of dealing with that, and AI could certainly be, I think, an element in that.
Wow, Tom, I'm gonna pass to Nick but you touched on autonomous systems and other aspects there. So a lot of different technologies there. Okay. Nick, your thoughts in terms of like AI and how that affects the public safety, and is AI really a good thing to have?
Yeah, well, there's definitely some challenges with it, but I would imagine everybody in this room has had the experience of doing a Google search where you haven't used quite the right keyword, and so the results that you get are garbage. That's something that AI is really good at, is you can give a pretty fuzzy description of what you're trying to figure out or do, and it will be able to parse that and give you a more useful result. So I think, I would also guess that not that many people in this room consider themselves data scientists, but when you add a capable AI in the mix, that's basically something that is open to all of us. You can ask questions about big sets of data that would be very complicated to solve, if you were trying to code something or figure it out. We definitely envision a point where we'll be able to say, tell me what's wrong with my building, and you will actually, without having to run SQL queries or anything else, you will actually get a useful response to that.
I was just going to say, it's worth pointing out that we've long used consumer technologies, and the big change over the last 50 years, like GPS was this military thing, and then the consumer version was better because there's a large market. So I think there's been a lot of talk about special public safety networks and things, but the real lesson is that the consumer technologies have the volumes. Like, as the AI becomes usable for normal use, it's used by public safety. So I think that's a real thing. We've got to understand that public safety is using consumer technology because that's where all the development is. The AI is just the newest twist on this.
Yeah, I would agree. And if you look at companies like Purple Air, who make an outdoor environmental monitor, they push all of that data up to the cloud and they make those maps very public. So, at a glance, they've got thousands of those units out there now, and anybody can go and see what's going on with pollen levels, particulate levels, you name it.
Yeah, thank you very much, Kathy, and thank you, Tom, and thank you, Nick. What I would like to mention is I'm also part of the Public Safety Technology Committee. I'm chairing with Stefan the operation for the initiative. It is good to see the digital twin for the sensing system and measuring the temperatures, and also for the coral reefs. And as Tom mentioned about the fire that's happening now in LA and back then in Hawaii. So there are many consumer devices and consumer technology across the aisles. But there is a very important thing, because we have firefighters, we have healthcare and ambulances, and we have the police force. But there is no common communication to talk between them. So how is the consumer technology perspective from IEEE to have a one platform for these people to communicate instead of talkie-walkie and radio and satellite? This is a very important thing, and the long time now in LA with the fire, because there is no platform of communication between these consumer technology devices. I would like to hear from you. Thank you.
But by the way, Tom, you mentioned the amateur radio group, and it relates to what Wahab just said. So maybe I could answer that for a moment. So
Okay.
I live here in Las Vegas. It's called Las Vegas, but it's actually Clark County. Las Vegas is a tiny little part of this. So we're not in Las Vegas now. We're in Clark County. The Clark County Fire Department also operates the Office of Emergency Management here in the area, and one of the components of the Office of Emergency Management is the Amateur Radio Emergency Services Group that provides last ditch communications with respect to that. It's a group which I'm part of, but with respect to what Wahab just mentioned, what exists here in Clark County is something called the MAC, the Multiple Agency Coordination Center. And it's a room about half the size filled with a whole bunch of tables and chairs and telephones and PCs. And the people sitting in that room are a combination of every possible public safety and public utility and variety of different other agencies that maybe need to coordinate and talk to each other real time. The fire department, the police department, the weather service, the electric company, the gas company, water department, the public works department. It goes on, and there's a linkage to the Office of Emergency Management in Carson City, which is for Nevada, and they have a linkage to FEMA back in Washington. So there is a mechanism that exists, and that's Clark County is not unique. Virtually every major municipality has a emergency operations center or a multiple agency coordination center where people can talk to each other. What they can't do is they can't talk real time with a cop sitting in front of a burning building and a fire department guy. They got to go back to the MAC and come back again, and they lose a lot of stuff. But by using text messaging now, and sharing that widely on, there are a couple applications, actually, consumer applications that tie to the cell phone, where somebody can send a message in and then it will get coordinated and distributed to everybody else that's out there, in a particular incident. So there are mechanisms for that are basically using some of the consumer technology to enhance what was people sitting around the room who would have to then talk to each other and pass messages. Now they can go directly from their phone to all the other phones of the people that are sitting out there. It makes a real difference.
So in the Southern California fires, again, I said that, my wife has some relatives living in Pasadena in that area. There were some of them in the state to defend their homes, essentially. So they were putting out fires, and their rogues crawling around, taking care of stuff. That's, they're not part of any official network. So their communication is probably going to either shouting to each other or using texting or things of that sort to try to communicate. Oh, there's a fire over here, things of that sort. So ad hoc communication.
CB radio, GMRS, ham radio,
Whatever.
or smoke signals. Pardon the pun, but yeah,
Smoke signals might not work so well.
yeah. Other.
Yeah, actually, I'll add, when you're talking about the fire responders, one of my co-chairs, Carolyn McGregor, she talks a lot about, in terms of like a user experience that people don't think about. So for firefighters, they've had to design like their body, what is it? Like their jackets and things, like communications.
Their uniforms, yeah.
Optics, yeah. So they looked at new and improved smart materials, so that the thing is, like for a firefighter, they can't really talk because they've got this huge glove on their hands. And so what they've done is they've embedded, they've redesigned new materials and communications that is actually part of their suit. And it's really impressive because the thing is, like, when people are creating the uniforms and everything, they don't consider from a usability perspective. And so I think that's a really important thing. And it's come a long ways.
Yeah, and just something to add to your point. One thing that I think some, not all, consumer technology has been much better about is more open and interoperable data. And that's something that traditionally enterprise and higher end systems have been very bad about because it's been part of their business model to be proprietary. And I do think that being more open with the system so they can connect more regularly, more easily, I think that's something that can be significantly helpful.
But by the way, Kathy, I appreciate that you intend to have a couple more chairs filled up here, and it's I guess it's an indication of what can happen when something goes wrong in the world. That we deal with it. But I just wonder if I might generalize this whole issue of public safety and maybe have you guys then talk about a little bit. So, you've been doing a deep dive, as you should, for people's expertise on things like digital twins and looking at the effect on the environment. But I think generalizing it, more to things that include, disaster response or actually individual, comfort and safety. So the framework that I kind of like to think about that the technology can end up fitting in different ways is a couple different dimensions. One of them is the prevention, where you monitor things, what's going on, and then you can do something about it. The other one is I'll call it detection, which is, the result of that is you sound an alarm. Something happened that you need to bring people's attention to. And then another dimension, so prevention, detection, another dimension then is analysis, figuring out, what's actually situation analysis, what's actually happening, as opposed to what you can see, but over the whole area, and bringing a lot of data together and that sort of thing. So those are three components. And then you got communications, which is then disseminating that and getting that information to people who can make decisions. And then finally, the last dimension that I think about this is the remediation. What do you do about it? You dispatch somebody, to go open a bridge or put a detour sign up or evacuate people or that sort of thing. So, in my mode, thinking more generally about this public safety, each of those different areas, there's consumer technology, the sensor technology, the cell phones we have for communicating, AI for looking at large amounts of data and raising an alarm and saying this is where the real problem is or whatever else. So, I guess the thing is what might be is happening within your domain, future directions, to kind of bring some of those things together, to look across those different areas and think about, where can we, as IEEE, develop standards or systems or bring together disparate different parts of the Institute, we're a consumer, we got computer communications, we got, all the sensor and semiconductor technology, but they tend to look within their own individual silos. And, you're a focus of the organization that looks across. And, is there something really happening that you might want to discuss it? Is bringing that together, or is a framework that I described a useful one for thinking about this?
Yeah, I touched on that framework in the very beginning, Stu, and you really pulled it all together much better than I could have. One of the things is we do have a bunch of standards that are in development as part of the Public Safety Technology Initiative. The other thing is we're doing the collaborations, like with the Singapore HTX group and ICCE USA and the truck program. One of the things is we're looking at like use cases, like early detection, particularly addressing like safety in public schools, trying to anticipate and look for monitoring and things like that from an application perspective, and any bad actors, because there's been way too many school shootings. And the idea here is to really set up a network that uses all the different technologies to monitor and then immediately trigger when there is a possible incident. And so that really helps to help safety.
I find it kind of amazing if you turn on the news, you've got these maps are showing, what's happening in LA at a level of detail, along with overlays, and indicate how many homes within this section have been destroyed, and the whole data visualization thing of presenting to you what's going on. And I assume that the professionals are reacting to that by dispatching more people or more aircraft with fire retardants based upon that collection of data fusion of visual things, as well as people reporting things in and people on the ground feeding information in and stuff like that.
Well, traffic control is also something to think about. There was cases where, people were abandoning their cars and the fires were going so fast, basically just escaping is people leave their keys in their cars so they can move them rather than having to shove them out of the way. But I heard over 180,000 people were evacuated. So just the traffic control of how, helping people to find ways of getting out of the situation is an important element to that public safety.
And even using not people, but drones.
Yeah. Yeah, the drones should be part, can be part of that as well.
Yeah, I mean, I think overall what's both fascinating and challenging about public safety as a topic is at the one end of the scale, you have literal global concerns, right? Whether that's a pandemic or meteorite impacts or things that are truly a worldwide issue, climate change, erosion of coral reefs leading to greater oceanic problems. But then it also comes literally down to the neighborhood, right? Like parking lot safety, school safety. Is this junction dangerous, right? This traffic junction, do we have the data to show how that can be improved? Yeah, and so, technology is great and can be a panacea for many things, but public safety, it's just such a broad topic that it's not going to run out of things to do anytime soon.
Yeah, I just want to build on Stu's point about the maps. That a lot of the map data is available because there's people like Google are using, they're going to steal our privacy. I'm not going to get into the negatives. But we have to, the question is, how do we work with enabling technology? In other words, the map is not a public safety map. It's an opportunity to build on. And I think often there's a tendency for these groups to try to solve an entire problem. And we really need to look at the underlying enabling technology. I think to the point that public safety becomes a special case, like one of the issues is trust relationships. That's just not an emergency. At the same time, we know how to normalize all the different communication. Got to be careful with my word. Communications technology is ambiguous. It means speech, people talking to each other, but the term came associated with particular technology. So it really is a step back. How do we sort of enable people to take advantage of opportunities rather than just create the solutions?
That kind of leads to an issue, you know, with security of data. There's things like GPS spoofing, for instance, that could be used to, you know, potentially in an emergency situation to not get people to where they need to go.
Or if you happen to be invading a country and you want access, yes.
Right.
No, well, these are all, I'm obviously not going to get into details, but yeah, these are, how do you make a resilience infrastructure rather than just, you want to make emergency not a thing, but it's resilience.
Yeah, I remember hearing about a performance artist, and as part of his performance, what he would do, he bought a couple of hundred cheap Android phones, and he would put them in a little cart. And basically, as far as Google Maps was concerned, he was creating traffic jams because there was a sudden density of GPS signals.
I'm sure there are people who do that for the local streets.
Yeah. So I'm hoping we can. I know it's very hard in a large room to energize some Q&A discussion, but you folks out there must have something to. Oh, then let me open up another vein, and maybe this will start something. So you can talk at public safety at this kind of, you know, amorphous general level and that sort of thing, and you know, it's interesting. Maybe another way to kind of come at that is considering we're the Consumer Technology Society, and one of the ubiquitous things that we're all carrying around is a cell phone. It's got visual, audio, text, communications, and that sort of thing. So maybe an interesting dimension would be to say, what can you do with a cell phone as a platform that will allow us to enhance public safety? To manage public safety, you know, in those different dimensions, in a disaster, personal safety, you know, prevention of things happening, like people getting sick in a building. You know, what are the kinds of things we might think about doing to enhance the devices we're carrying around today that'll collect the data, feed it somewhere, analyze it, and allow us to do something about it?
And I think you're already seeing that start to creep in. If anybody here has used Android Auto while they're driving with Google Maps fired up, right, increasingly you see the little pop-ups saying, oh, there's a stalled vehicle, is it still there? So they're directly crowdsourcing additional information. So, you know, it's easier with platforms that are as ubiquitous as Google Maps, obviously, but I do think that thinking is starting to be more common.
Yeah, it's really into the apps too. There's more and more apps that are coming out that are intelligent enough and helping guide, just like the Google, but also from a biometric perspective, the phones are being smarter and smarter, and helping to monitor, you know, the air quality, your own biometrics.
Okay, this is Rock from Spain. Talking about public safety in Spain, we have like a recent flooding, like 3 months ago, in the region of Valencia, where it was like a sudden rain, and then there was a big flooding, and around 250 people were died. And looking backwards, there was all the data was there. I mean, the rain data was there. But there was one problem, that is the human decision. The data was there, and the person taking the decision to send the alert to the people, it took 2 extra hours to press the button and send the alert, so many people couldn't do it. There is now the controversy of course, if there was AI processing all the data, at one point, that decision could be taken faster and send the alert before. So I would like to know your opinion about how or what protocols we can make to AI take decisions of human. I don't know if it's the question understood or not.
So it kind of gets into thresholds. When is something, when you declare it an emergency, and it depends upon, right now, a lot of it depends upon human decisions and your skill in doing that. And, are you evaluating, do you have all the information, and are you making a good evaluation, right? Conceivably, if you have that AI could help, if we can train it on those things for people to be able to make predictions and have a better idea when something is actually an emergency. The other thing that can happen, of course, if you're always calling it an emergency, but it doesn't happen, then people get tired of that and they won't respond. So that's what I mean. It's a matter of how do you do the thresholds and how do you make the decisions. I think that, properly trained AI, especially if it's trained on edge cases, which don't occur very often, might may assist people in making better decisions and, identifying something that truly is a danger sooner rather than later.
Yeah, sorry.
So his question was, should we allow AI to make the decision? I do not think we're ready for that in most cases yet, unless there's no other option.
Well, at least the science fiction movies tell us we shouldn't do that, right?
So
we should limit how much we let them.
Yeah, I don't have a good answer for this, but we've already got studies. So for example, self-driving cars, right? This is something that's been promised for a while, and obviously the developments in AI are driving improvements there. And so the current status quo is, most of the time, is that the vehicle is driving autonomously and some poor human has to sit there ready to intervene at a moment's notice. And the initial studies that have been done have shown incredibly conclusively that that is a terrible setup, because most people get lulled into a false sense of security and get very comfortable sitting there and assume it's going to work. And so their response time and their ability to interact when they need to is massively diminished. So I do think that you need human in the loop a lot of the time, especially when, right now, the LLMs, the large language models that are so prevalent in AI, we can't clearly quantify exactly how they are going to respond to different things, because it's not, the dials that we're reading aren't directly connected to the levers that are being pulled inside the black box. And I don't know that we're ever going to get to the point where that is absolutely clear. And when it's not clear, you run a non-trivial risk of inadvertently alienating or penalizing different groups that were not in the training data or were misrepresented in the training data. So you can lead to, I don't know, areas of a city that are being under-policed or over-policed because the AI has, for whatever reason, made that leap that, oh, this is a bad part of town. And it's not a bad part of town, it's just the way the data was skewed when it was pumped into the AI in the first place. And we do not have any reliable mechanism to detect that kind of bias in an AI model. And you see it, for example, there's a very famous case of or well documented, I should say, of a cancer diagnosis tool that was AI driven. And this was actually rolled out in clinical practice, I believe, in parts of Europe. And its job was to second guess the technicians in terms of analyzing images for potentially malignant skin cancer. And basically what they found was that through the training data, much of it, if it was a malignant skin tumor of some kind, it would have a ruler in the picture, because it was usually quite often post-mortem and it was being used as a case study. And so the AI made the intuitive leap that if there was a ruler in the picture, it was definitely going to be bad news, full-on tumor and cancer. And this was actually used in practice until they realized that it was misdiagnosing. Anytime there was a ruler, it was 100% certain. There have also been awful examples in the US where AI has been used in the criminal justice system. And you get two people side by side whose skin color varies, And, you know, the white person gets a much lighter sentence, and the other person, you know, a person of color, is at the opposite end of the spectrum. There was a very prominent case again that I think actually ended up, I think they sued successfully in the end, but there was a African American woman who had committed some minor shoplifting. And a white defendant who had a history of grievous bodily harm and abuse and so forth. And he got off with a warning and was basically committing crimes again within 6 months. And she was sent to prison for an extended sentence. And again, when we take the human out of the loop and we don't understand quite what these biases are, you're setting yourself up for a lot of really difficult challenges.
The only quick comment is that the AGI test is if the error is human, you know, put it this way, it's unclear. We're not quite ready to go with AI for everything, but let's not forget how badly humans do on these same things.
It's a good point, and that's why I said at the beginning I don't have a good answer for it. You know, there's a lot of talk these days about AGI, right, advanced general intelligence, and the sort of handy metric that's thrown around is an AI that is smarter than a human, right? That's sort of the. But right now with tools like Claude and Perplexity and ChatGPT, it's already able to answer many questions that even most of us, you know, who I'm sure, you know, we all consider ourselves to be fairly smart, would not be able to answer because it can cover so many different fields. I mean, you know, I've used AI extensively in our product development because it can tell me things about building science that I never studied, statistics that I've forgotten, materials properties that was 30 years ago, so I certainly don't remember that, and so forth. And it can very neatly tie all that together. So I can ask a very fuzzy, fairly dumb question and get a really intelligent response that I would probably not be able to get from a single human. Yeah, yeah, yeah. So yeah, it's fraught with difficulty for sure.
Yeah, the reality is AI is not going to take over humans. It really requires humans and AI teaming together. Got a question over there?
Yeah, I think there's maybe an instinct to blame or be skeptical of AI for things like this, but you could recurse that question into complex technological solutions for a lot of issues. I was just talking about, I have a family member who is very close to the fire perimeter in LA, and they're evacuating, and they have a very sophisticated wildfire protection system, sprinkler system that they tried to activate before they left, and it's not working. So when you're in that situation, you don't have time to troubleshoot a complex system with some unknown failure in it. If they just had something like a valve to turn on a garden hose on the roof, that would probably be sufficient. But they don't get to do that because they invested in something very complex. So and it failed on them in the moment of need. So, you know, I guess the question descends all the way down. Is a high-tech solution always what we need, or at the very least, should we build in manual redundancies at every level?
Yeah, so I have an anecdote from earlier in my career. I worked for a company that took scanned architectural plans and converted them automatically into CAD drawings. And they had invested a great deal of money in symbol recognition. And this was the mid-1990s, and they were one of the leaders at the time. And we had about an 85% accuracy rate on identifying, oh, that squiggle means it's an electrical outlet, which we were very proud of. And there was a competing company that, bluntly, their technology stack was nothing compared to ours. It was amateur hour. We were very fond of dissing them in many ways and had the data to back it up. And we consistently lost bids to them. And I was a product manager at the time, so I was fairly determined to find out why. And I went to one of their demos. And here's the thing, if you're 80% right, you're also 20% wrong. And what they came up with was a system that didn't even bother to try and convert the symbols. They just looked for things that were messy squiggles on the drawing. And by hitting the tab key, you could go from one to the next as the human, and basically a pop-up menu would appear and you pick the right symbol. And so in a fraction of the time it would take to clean up the 20% that we got wrong, they could process an entire drawing. And I think another example would be Amazon warehouses, right, where identifying objects on a shelf and picking them off is still a fairly challenging computer vision problem. So Amazon brings the shelf to the human does that part, and then the shelf is taken away. So I think it has to be a balance. And I think another good example I heard, I think it's the wisest thing I ever heard anybody say about a smart home setup. They were talking about how they'd automated all of their lighting and it was fantastic. And then they realized that they no longer had a single working light switch in their house, right? And so they went around and figured out a way to basically have a mechanical switch that could override the system. To your point, because sometimes it doesn't work.
You need to back up. So I just mentioned one other thing, and I guess we're getting to the end, the close of this thing. I took a tour a little while ago of at the operations center for the Nevada Department of Transportation, NDOT, and I was surprised to learn, first of all, Clark County is immense. There are thousands of intersections and traffic lights. Every single traffic light in Clark County has a fiber optic cable that goes back to the NDOT operations center. There are cameras at some of the intersections, but even where there are no cameras, there's traffic sensors as to how many cars are going through. The operators at this NDOT facility sit in a room that they call the fishbowl because it's covered with monitors, one end to the other. But they're using AI for, I think, a really terrific purpose, which is this combination of man-machine, this sort of thing. The machine determines whether there's a monitor that's worth looking at. And it basically lights it up, it sounds a little bell, and people can look at the screen on the wall, or they can use the workstation in front of them and zoom in on it and zoom around and look and see what's going on. Then they could dispatch fire, police, ambulance, or whatever else is involved based on what they see. But the machine isn't making the determination about what to do, but it is bringing this massive amount of data that you can't possibly absorb to the attention of an individual that can then make an intelligent decision. So I think those sorts of examples, I think where there's lots of sensor points and lots of data and can make decisions, I think are a great example of where we can generalize it to more public safety stuff.
Yeah, I remember a conversation I had probably about 10 years ago with a fairly large industrial company, and they had instrumented all of the machines in a particular plant that was processing paper. And so literally every step of the entire production, they had data now for it. And they were very proud of this, and they'd spent a lot of money doing it. But the guy was complaining that it took a good 6 to 9 months to train new people up to look at all that data. And he described the room, and basically every single machine had its own screen in this data room. So they've got hundreds of screens, all of them showing disparate data with no filtering whatsoever. So some poor sap has to sit in there and just try and absorb all of that and make sense of it, which it is crazy. And I think using AI to help filter that, again, as long as you're cautious about biases and things, can be very helpful to basically find the signal in the noise.
So I think we've actually used up the time for this session, and again, I want to thank my appreciation to Kathy for putting this thing together, despite losing a few people on the way. I think it was an incredibly interesting subject, and I hope we in the Consumer Technology Society, I'm sure at IEEE, the institute level, will continue to pursue this. But let's thank the panel for being here today. Okay, just a little roadmap here. If you look up at the screen, we're now entering into the lunchtime session. As soon as this is over, there actually will be lunch in the next room. So I'd like to invite up the WEI chair, and she can then introduce our speaker.